Hello, everybody. Thank you for coming to this talk. I guess you are interested in teaching, so do I, and therefore I propose this talk, how to teach modern C++. So what we'll be talking about today is just about students or class organization, time planning. So all these details, we start with various groups of people. But the most important and the longest part of this talk will focus on some teaching scenarios. So I will not give some ready recipes, but some scenarios how you can proceed with absolute beginners, with advanced groups, and also when we go farther and farther, and I will also present this 2080 paradigm, which I am just using in my mind when preparing some materials. Swimming, teaching swimming. I'm also a scuba diver and teaching people swimming and scuba diving, so I have this experience as well. But the point is good examples. So this is one of the most important things when teaching is giving good examples. And also to keep in mind that we live in real environment, so we need to know about legacy code and other things. And at the end, I will present some materials, some web pages, some books, so we'll postpone this till the end. But first question, why I was brave enough to propose this talk and get accepted, because there are many talks on teaching, so many people are really interested in this. Björn Straustrup had this talk in 2017. Also, this is very interesting talk if you are just in this group of people. And also, Christopher Di Bella gave the quite interesting talk. I will talk about Chris because we are cooperating this SG20 group, which we propose some teaching materials. What I do and whom I teach. So, sorry. I'm working at the university, mostly, in Kraków, in Poland. So this is quite huge university. It was science and technology, but it was mining and metallurgy, but gradually with years we changed to modern technologies, and we have a lot of students and a lot of 16 faculties, and we teach informatica, computer science in many of them. So we teach a lot of languages, but what is important is just to prepare some schedule of teaching for a group. And we always lack some good materials. In many languages we teach, we always are looking for good recipes and good materials. So, but actually I am a scientist working at the academia, doing research in computer vision, machine learning, artificial intelligence. So if you Google my profile, you will find many publications in this area. If you go to Amazon.com, you will find books I wrote on computer vision. But I have also more than 25 years of experience in teaching different aspects of computer science, but mostly modern C++. So each year I have hundreds of students, but about 100 I teach with my group of cooperators, something like 100 people. So this is a lot if you multiply by 25 years. But these are students of electronics communication, computer science, but also faculty of humanities. I'm mentioning this because this is important. This is very important. Who you teach is you should start preparing your classes from this question. But I also work and cooperate with companies, and also my students are working in the companies, so I have feedback from them. I'm also an engineer working in writing C++ on daily basis, but I'm also a student. So this is also the key point. We no matter how old are you, we always need to develop ourselves and learn, because the technology is changing so rapidly. But regardless of academia industry position, so I would like to point out that we are all teachers, or likely will become teachers. Even if working at the company and you become, with years, a senior software engineer, you have your younger colleagues and you become teacher. Yes, so you can take some methodologies of teaching, of presenting, of verifying their actions from my talk as well. So let's share some knowledge. So I know that this lecture will be a little bit subjective because I'm presenting what we developed for years, but I would like to hear your opinion as well, because we all have. So we have all different experiences, but to start, probably we all agree that C++ is probably the most powerful and versatile language used today. But unfortunately, this makes it difficult to learn and teach. Yes. So I found this image. I like it for many reasons. Maybe I was inspired by Top Guns and Maverick. But it is something true in this image that starting new experience like a student, like a learner, is like taking off a plane. But sometimes it can be difficult. Maybe not that difficult like in learning how to fly, but also we can be intimidated by many situations, also in C++. So this is our teachers' responsibility to make this process safe and fruitful for everybody. So, but I put these images for purpose. Well, majority of images in my talk are for purpose, just to think of this very crucial beginning period of people taking off in this domain in particular, but in many domains when they start learning something new. This is a very special moment. They are very open, and we cannot spoil this time. So the first lessons, 1, 2, 3 classes, 3 weeks are very important. So this is why I like this image and to remember about it. By the way, it is interesting how much C++ code we have in these machines. Yeah. So let's go to merits. First things first, organization. So first thing, please know your students, know their background. So we cannot, in other words, we cannot go to a group of people we start teaching with the same attitude. We should know something about them, about the background, what they already taught. So are these absolute beginners, for example, from the high school, or students of electrical engineering or computer science? Majority of my students are like this. Or what they have already learned, maybe Python, other languages, maybe a little bit of C++, and usually they are not equal. Some know Python, some know C, things like this. Or maybe professionals. We sometimes have lectures for professionals. They do code and they are doing this well for years, but for some reasons they want to go farther. Or maybe kids. We have classes with kids as well. So why they wish to learn C++? At the first point, because C++ is beautiful. Maybe it is, but probably this is not the only one purpose, yeah? Or maybe they are forced to. So we'll organize the classes. So, okay, the first thing, I know my group, what they begin. Now I need to organize the classes. And here comes this image, also for purpose. It's a whiteboard. I remember times with blackboards and the chalk. But the thing is, we made our lessons in different manner back times. Because when I start writing something on the whiteboard, it takes time. I need to start from the beginning. Usually we don't write the code linearly. We start with the function, we finish the function, we have to put things. Now we do differently, like in my presentation here. I put slides on, and we go further with the code. It can be too fast for students. So please remember this whiteboard times. Be sure what you want to achieve. So the thing is we need to put precisely our goals. Have a plan, okay, so we have a plan, but react on student progress and expectations. So be agile. We know this methodologies from software development. So we will see many methodologies from software development right here. Be agile. React on how your group is progressing. And also, your teaching colleagues, your group of teachers. But I'm not teaching alone. I have a couple of collaborators, and they can have different levels of understanding C++, different aims. So you have to control this as well. Also, I need to control my time as well. How to plan our time. I like this image by Salvador Dali. Okay, so another important aspect is time. Yeah? I already mentioned that this beginning moments of taking off are very crucial. But how much time do we have for the whole lecture or the course or, I don't know, the study? So we need to adjust to this. Is it one semester or a week or 3 or whatever? And how to organize the classes and the classwork, the next question. So, well, usually we have labs like this, but what about the teamwork? Do we start with the teamwork from the very beginning, and we foster this way of writing and behaving, I would say, or we just put some pressure on single work, on some, for example, exams or tests you write by your own, not in a team, certainly. So how to choose and what teaching materials, what website and what books. I will come to this a little bit later, but this is important question. At this time, you organize your classes because you have to propose something to your student. They will be using this. And the important thing is, if they use the book A, they will not probably use the book B, and vice versa. So this is also the crucial moment. Okay, so now we have time for this longer part. You are probably interested how we do this. So what we can propose, how to organize the classes. So I split this into a couple of groups, absolute beginners, advanced, and so on. So let's take a look at some overview of some teaching scenarios. Yeah. And at this time, we'll be talking about teaching scenarios, so some maybe not very detailed plan, but something like table of contents. But we'll stop for a moment and consider this 2080 paradigm, which I would like to point out here, just to have in mind. Well, introduction to programming. Certainly, everything will have introduction to scuba diving, to programming, but what to start from? What tools? Install GCC or Microsoft or web compiler? What is the best? And what if students want, this guy wants something else and the other one, do I need to force them to use GCC? Or it can be just free, use whatever you wish. How to present C++ concepts? Prefer a presentation, like a lecture, or just live coding? Yeah? Or just our lectures with PowerPoint slides, of live coding, or this whiteboard? Yeah? But before we go to some recipes I can propose, let's consider a very useful methodology, this 2080. Probably you have heard of. It is, the other name is Pareto Rule, or Law of Vital Few. I just copied the names from the Wikipedia. I'm glad we have Wikipedia because we need to have some solid materials on the web as well. So it states that in many life situations, 20% of causes is responsible for roughly 80% of consequences, results. So how we can make it work for us in a moment, but Pareto, he was an Italian economist, and he observed that 80% of land in Italy was owned by 20% of population. So also they observed that 20% of workers contribute 80% of results. So what's the conclusion? Focus on rewarding these employees. Yeah? But in software, there are some Observations. This is some heuristic observations. It's not the strict rule. You can say 10-90 or 30-70, but usually many things in life go this way. So 20% of bugs contribute 80% of crashes. So focus on fixing these bugs first. Or 80% of CPU time will be spent in 20% of code. So find out this code and optimize this code, this 20%. But also we can think of users. 80% users are using only 20% of applications features. So probably preparing the slides, I used only 20% of possibilities of PowerPoint. I don't know. But the key observation is that most things in life are not evenly distributed. So some contribute more than others. And we'll use this rule, well, just observation, in teaching. Maybe not in teaching, but just when thinking of preparing the classes. So the point will be to find out this golden 20% of what we need to start from. And we can draw such a plot. The linear, so the more you put effort, there is the same outcome, but in this Pareto rule, you are somewhere here. So therefore, I was mentioning this steep takeoff. Yeah? But it can be very rewarding if we choose this good starting point. So the start is the most important for safe landing as well. Okay, so focus on the important 20% of content. Now we return to teaching. And having this rule in mind, show some concept, get a general direction, and then work out the details. See what features generate the most results and give them your appropriate attention. And then move on toward the more advanced material and apply the rule again. But you can ask me, so is it brilliant? Is it a recipe for everything? You reinvented the wheel? I would say no, that the rule is just an observation. But once I realized that I am conscious of this 2080 and I'm starting thinking of many problems, also writing software in this. Okay, let's start today on 20% of important features. When you talk with your group about your software, just start from this important stuff, yeah? So also in preparing the classes, when I think of this important aspect, so in all these teaching scenarios, I will just focus upon this 20%, in my opinion, of important concepts. So let's come finally to these recipes. Let's assume we have 1, 2, or 3 semesters for the classes. Usually in our university and in my group, it is organized like 1 lecture a week for 2 hours and 1 lab, which is 2 hours, and also students then have their own projects. So usually there are these 3 parts. So they come for 1 semester. But we can do a lot of things in 1 semester if this is organized quite well. And so what we can achieve? So we need to ask this question always. So for each step, so for each, I would say, iteration, we'll come to iterations in a moment. Define the main goals. We can keep this 2080 rule in mind. Define the minimal set of C++ features you wish your students to acquire, 2080. Define the list of optional features. So what would be good to know if I have more time, if the group is advancing quite rapidly, and so on. But know your students. And Björn Stroustrup said, keep things simple. Einstein said this as well, but in different framework. C++ is complicated enough, but I would say, rephrase this, keep things simple and in proper order. And also be agile. Be agile. I already mentioned this. So react. Okay, you have your plan, but you cannot follow your plan not observing what's going on with the classes. We make tests. Well, it's up to you how frequent are tests. You give the notes or not. But be agile. So adjust. Sometimes you need to stop, repeat something if you see that some material is too fast. And remember that we teaching, for example, for 10, 5, 20 years, we have some habits. And we don't understand with years how it is difficult to start, to make this take off. So this is important aspect. Now the scenarios. Absolute beginners. Who are absolute beginners? Well, you decide. Maybe I am an absolute beginner. But so for absolute beginners, like kids, or you just start with a group and they don't have much or any background in computer science, explain the computer. This is very important to build some API. So this is one of the images of a computer I'm using. Build understanding on levels of API, application programming interface, yes? So at certain moment, I don't go further. I don't go to transistors, to gates, but memory, if you have more time, show something like this. Well, for me, it is the lowest level I go when teaching C++. My first faculty is electronics, so I did a lot of things in electronics, so I can go deeper and deeper and deeper and do some things. But this is the level for maybe assembly, if someone is very keen on understanding on Godbolt web page, what is your compiler doing, yeah? But this is something, remember, this is absolute beginners. So explain what are computer languages and what is C++. Maybe they don't know. Explain software development ecosystem. I call this ecosystem. So what is compilation, what is linking, debugging? So actually, a computer language are the means of talking to the computer, yes? What it's supposed to do for us. So the language is just a medium. It's not that important. It's important to know what I want the computer to do. So this is the thing, but I was mentioning about the tools, so we always will return to these tools. It depends, the complexity. I put the entire image here, but the complexity depends on your group. So you can skip the profiler, but debugger is the must, and compiler is the must, and the linker will be somewhere behind. Explain the step of software development. So this is another important aspect of teaching C++, at least in my group. We don't teach C++. We teach computer science and C++. So C++ is just a beautiful language, very powerful, but this is not the point to teach only C++. It's just teaching a little bit of software development, an occasion of teaching C++. Remember, the times are very fast. We don't have time to go slowly from data structures plus algorithms that equals programs and so on. We have one semester for everything. Yeah? So teach this. It is not much time to show that we need requirements, we need problem analysis, solution design, implementation, then go the code, but also testing and debugging, system deployment, system maintenance, and on occasion you can show some UML. Why not? It's quite fast, and your students will acquire more knowledge about UML, about software development, a little bit with C++ in main focus. Yeah? So that's the thing. Show how to express algorithms. They can be expressed in text. They can be expressed in UML activity diagram. Name it, activity diagram. So your students will know activity diagram. In a moment, they will know class diagram, use case diagram. So why to spend another semester for teaching only UML and some software development methods, maybe advanced, that's okay, but on occasion you can do much more. So this is another point of my talk. Don't teach only C++. Teach computer science with C++. Present and explain a simple C++ program. Remember, we are in the group of absolute beginners. So what we do usually, we start with such a, let's say, boilerplate, or I don't know, main. Okay, this is your program. You can compile it. You can test your installation. Remember, I mentioned we need some tools, GCC or Microsoft Visual or Visual Code or whatever, yeah? Just convenient for your group. So this is your first program. You can run it and you can have, but explain everything. Explain everything. It is good to write this on the whiteboard because you start with something, you go this way, this is. People observe how you behave, not just, okay, this is the program, compile it. Well, so, but then you can add a variable, object. Usually we stop with double and int at this point. But show initialization, show we need a semicolon at the end, but no semicolon at the end of the function. Show how to input the value. Although in the previous step I initialized, in the next step I can change it. Show if, and show some calling of some. This is one of the first examples I have, but you can devise dozens of such. So, but what is the point? For absolute beginners, our framework is single main. They don't write functions yet. They can use functions. This is what they need. If, double, int, cout, cin, that's all. And you can build a lot of stuff I will show you. But explain everything. Then go somewhere to, maybe for the first class, they are not organized well yet. They didn't install the programs. You can help them. But you can go to the web page and just compile this program. For example, well, this is not my favorite. I just show them many. Maybe this compiler explorer is not the best because it is showing assembly. So people will, what's that? Let's add a, no, well, maybe something simpler will be better. Show your favorite web compilers, but don't insist on one. Usually we use Visual, Microsoft Visual Studio, and GCC. We have Linux and Windows following like that. Because we have students of electronics, so Linux terminal is a must. But sometimes it is faster to start in IDE, but remember, IDE is huge. IDE is, you don't use 20, 80%. You use 98% of features of IDE. So explain basic functionality. Make some scenarios for them, or write just a recipe for them how to use IDE. Show where to read, learn more, yeah. And now the list of minimal but productive. So this is my 2080, yeah? Main, libraries, using directive, but not using namespace std. No, using std, cout. Using std vector. Printing, cout. Define verb, int and double are okay from the beginning. Entering values, cin, conditional if, and some logical conditions, vector, string, and 2 versions of for. This is what I came, that one is not enough. Always there will be interspersed in the code, so I teach them both at once. For and range for. And that's all. This is my 20%. And we need examples. I will show more examples in a moment, but here are for the beginners. So first group of examples are all the computations. I will give you some materials at the end of this talk. But I have one example here. Very simple. For example, to compute frequencies of letters in a text. So what we are building? A histogram. Well, what is histogram? It's a data structure. So we teach them a little bit more. And what we can do with the histogram? We can normalize it and use it like discrete probabilities. So we can build on this. We can show some connection to math and to some real computation. So let's start with this. So again, main is our boilerplate, our framework. And we start with vector. And what we wish our beginners, absolute beginners, just to know how to initialize a vector. So it has 2 values, how many bins, and what the initial value of each bin is. And explain what I'm doing here. I'm subtracting z minus a plus 1. What's that? Explain. These are ASCII codes. So if this is one letter, A minus A would be 0, therefore I'm adding A, and so on. So this is what they should understand. Okay, I create a vector, it will be empty. If I want something to be inside, I need to put two values. How many, and to start from what value. String can be empty at the beginning. We can enter the string, but sometimes on the web pages it is not easy to enter something, so we can also initialize with some text. So we can explain that that string is containing the text, but I can write the text just immediately in the code. And we have the first for loop. So we start with this. We say, okay, auto is just compiler will find out what the accurate type for C is, and C will come through each letter in this input string. That's fair. But the first thing, there can be errors. You need to be, okay, careful. We have only slots for small letters. Yeah? No capital letters, no digits. So if we don't check it, we'll generate probably some trouble. So show them to be careful. Also, what the user is inputting from the keyboard, it can be anything. You expect a number because you are computing some values. Well, it can be any text. So it's alpha. What is alpha? It is something written in the library which checks if my letter is alphabetic. And then the third line, I increment each bin in the histogram by ++. And how I found out which one, I am just taking the code of a letter, just transforming into lower letter and subtracting the first because they are organized in the increasing manner in the memory. Just like this. And show coding style from the beginning. This is my coding style. But don't enforce this Kernighan-Ricci style or whatever. They can choose. But we can talk about this later. And another loop just immediately after that. Because we want to print all the characters, so it will be easier to have this loop. So we explain, okay, we start from K, and proceed, and then we go. And again, because we have already computed the histogram, we can display the values of the histogram using the previous, and because this is main, we can return 0, we can explain this. And this is the result. One of the simplest, but I wanted to show you some concrete we use, yeah? But you can build on it. But the point is the set of features. And my point is, with this set of features, vector, string, for, if, you can do a lot of nice things. I will show you some examples for beginners in a moment. Not going. Updated teaching model. Again, well, we know about this 20-80%. That's fine, we are applying this, but we have more. You see, beginners, advanced, then again vector, it resembles the spiral model. Why not think in this terms? We are using this, maybe not, but this is one of very well established, known methodologies of software development. So just copied from the BOEM. It's a spiral development family of software development processes, characterized by repeatedly iterating a set of elemental development processes and managing risk, so it is actively being reduced. So this is for software development. Here are the credits, but I would rephrase this. I found this image. So for me, the spiral model when teaching is something like going up the spiral stairs. I adjusted the spiral model to teaching like repeatedly iterate of a set of teaching processes, increasing level of details. What I mean, you'll show vector like I just showed in this example, but then you go again with the vector and you show more. Then you go again and you show how to make a matrix out of vectors and so on and so on. And you go up. What about risk management? We can talk about this a little bit later, but certainly be agile. So the risk is you go too fast, or your set of features is not appropriate for this group or for the progress. So you have to think of this. So in other words, you don't follow blindly your path. Okay, yeah, I need to make lectures. I don't care. No, this is a wrong way. Okay, now basics. Okay, remember, we have absolute beginners. We started, this is maybe 3 weeks or 2, depending. They installed everything, they started the main, there's a couple of examples. Now the main takeoff is taking the place. So again, the minimal list, what is the minimal list at this level? So again, I'm thinking, okay, 20%, not too many. Built-in data types, more. We know int, Boolean, but probably char and int and double, but we need to know Boolean and char. Code debugging. I start with code debugging from the very beginning. There is no button run and format hard drive or something. But for some reasons, maybe my students, but in majority, they hate debugging. I don't know why. They hate 2 things, actually. Debugging and writing comments in code. So this is what we foster, but you start from this. If you go observe students, put the breakpoint and you go step by step. Then your eyes are open. Okay, I wanted this and the computer did something different. Why? Yeah, so basic members, so we go spiral model. Vector, we already know, but we go farther on. A matrix, vector of vectors. Basic of string. String can hold, but it has some functionality. Auto. Common standard algorithms. Okay, you know how to write the loops, but you don't use the loops everywhere. If you need to copy something on the screen, use copy. You have it. Or generate, accumulate. We are showing this in the very beginning. Structures as data containers with struct. So no members yet, but okay, I have vector to hold objects, but I can have one big object holding, for example, vectors, and they can be interspersed. References, non-pointers. Statements, so here also exception handling, a little bit at least. Functions, most important thing, going from main, you need to write your own functions. And lambdas. Again, beginning, then the spiral model will return to lambdas later on. Intro to struct versus class with a constructor and few members. So we started with basic software testing, operators, and that's all. If we have more time, we can go with tuples, structure binding, random numbers, pointers, memory operations. Why? Because I have students of embedded systems, operating systems. So they, sooner or later, rather sooner, they will see 3 RTOS, and they need to connect, and they have this char pointer something, and they need to understand at least. But the thing is, they already started in modern C++. So pointers is something auxiliary, not for everybody. It is, but remember, keep things simple and in the right order. So know your students. So we need to, for some, we need sooner, but for some, you can postpone pointers till the end. Toolchain, CMake. More arrays, but not int and old style. Array is okay, because sometimes it is more efficient than vector. But know your students, again. For example, there are embedded or game developers or things like this. So now we have this scenario, a little bit upper level, object-oriented programming. So what to concentrate on? So the minimal list will be certainly, remember we are building on top of previous lectures, so intro, object-oriented programming, anatomy of a class, more about classes. So at this point, they should be flexible and comfortable with writing their own classes. Write references, but not necessarily forward references at this time. Classes with all special functions, and move semantics explained at this point. Remember, this is the 3rd level of teaching. Templates, generic programming. Virtual mechanism after that, at least in our schedule. Some design patterns, what I mentioned, teach more on occasion. Showing an example, you can show more. Don't stop on showing sort. Just ask people to write your version of sort. They can learn more about algorithms at this stage, about very useful wrapper, handle-bodied, and proxy, for example. Memory management at this point. Right? Unique pointer, shared pointer, weak pointer, usually we mention, but our observation is use unique pointer. If you need something more, explain me why. If you have good explanation, go on. But people are overusing shared pointer. Why? Because it is easier. You don't need to, I cannot copy, why? I need to move or something. Yeah? So advanced C++. Remember, we finished this. Mm-hmm. Yeah, it is. Okay. Maybe I will explain the questions at the end, but, well, we can discuss, but in our opinion, you don't need smart pointers if you use vector. In many, many examples we have, it is quite unusual to ask people to allocate something directly on the heap. If you need the buffer, you have a vector. Explain me why you need unique pointer. So therefore it is this way organized. But it depends, Okay, we have this advanced concept. So this is, well, we can discuss what is important, certainly. Where to go from here. So the higher we go, the toughest it gets. But again, minimalist in our classes, class hierarchies, file system, universal references, regular expressions, graphical user, because they know how to use classes, system clock, things like this, expression parsing, for example, for advanced syntax trees. We can teach more design patterns, showing some simple grammars, things like that. State machine pattern, it would be useful. Remember, we have electronic engineers, so state machine. Basics of power programming. This is quite interesting thing. But very important subject, we just skipped it. Okay, these are our scenarios. Now, let's go to examples. Very important, very big font, very important. Two things, good examples and cooperations with the teacher on code refinement, what students wrote. Well, again, can we swim? We have water here, so we can start. The role of good examples, but what are good examples? They should be comprehensible, not too long, touch on real problems. This is very difficult. When preparing our teaching materials, the longest it took us to devise some examples. Usually they come from our work, daily work as software engineers, and also observations, what students write and in what manner. Can be extended into more advanced versions. So what we really care of is our examples which can be incrementally built. So you start from something simple, then you add something, then you add some functionality. So I will show you some examples. And how students can use examples. Compile, make it run, just like this. Okay, you press the button, you observe something, maybe you put the breakpoint, or retype. Okay, I have this in the book, but I change the names of variables, I control, but I'm just, I have this text. Or don't use it. Okay, you know what you are about. You have some class diagram, for example, make it by your own. Or use as a startup for your own project example. This is very important, last point, because the good examples will serve as code snippets for students. There is even more. Good examples are making some patterns in our head. So once we bounce against some problem in software world, okay, I had this problem before, so I can look up my code, or I know where to look it up, and I can use it, and I can rebuild it, and this is very important because we are thinking in terms of snippets, patterns, and so on. Student projects, now they go on their own. But don't leave them. Just give them a note, and I go on vacations, they go. No. Just sit down 15 minutes, 45 minutes, and do code refinement with the student. Single per single teacher. And this is very important. I will show you some examples in a moment. So examples for beginning. We don't have much time. Simple game for beginners, card play, good, or secret chamber. Like this. So remember, we don't have classes, we don't have GUIs yet, But in the terminal, we can do something like this and describe the algorithm in terms like this. So the work for students is just transform this algorithm to the program. We found out that such group of examples of projects for them is very rewarding and funny. For basic learners, a matrix, we can do vector of double, that's fine. But then we can, make a wrapper in a simple structure, and finally you can make a class matrix. So how we proceed? Step one is just like this, using, and you have real matrix like this, okay? It's a matrix, but you have a problem initializing this. Let's try to make a matrix 3 by 4. We will do this, but to explain this to students is not that easy. So in the next step, we can take the same real matrix from the previous slide and wrap it around a structure, in a structure. So what we are showing, how to deal with difficulties of initializing, and also showing a design pattern, wrapper, very important, especially when porting from older code, called also adapter. Yeah? So how we proceed? Okay, we have this, and we can add at this moment non-trivial constructor. So observe, we don't have default constructor now. But what we achieved, we can initialize the matrix with some values, and assure that we don't have 0-0 matrix, because it is not well established in mathematics what is 0 by 0 matrix. And moreover, we can show some values, default values in the constructor initialization but also we can show programming by contract. Remember, teach them more. We can have some assertions. They saved my life many times. Well, programmer's life. I was not fired from the company, okay. But use it. We'll have probably programming by contract in the future C++ building, but assert is working quite well. Show them, and some helpers. And the third version, okay, you can build on this matrix, you can show also some contract, and also some algorithmics here. Teach them how to multiply matrix. You can build upon this example when you are teaching parallel programming, because changing the order of the loops will change the performance of your code. And the third version is fully fledged class. So what does it mean? The data will be private. Explain why private data. And what does it mean? This is the same, but data is private, so I cannot access my data quite easily. So what I need to do, I need to overload some operators, subscript, another subscript, const begin, explain the iterators at this point, explain the other overloaded operators, and so on. We have a lot here. So this is a beautiful example. 3 steps. Yeah? You will find the code on the GitHub, so I will give you the address. And you can build up on this a lot of good stuff. Like this, you can add some random initialization. So people are learning a lot in this simple example. For more advanced learners, another example in couple of steps is very simple, currency exchange. We are not in, Poland is in the European Union, but we have Polish zloty still, so we have to recalculate, or you recalculate from British pound to euro. This is simple, just the first version for beginners. Beautiful example in the main, yeah? You have currency ratio, values, multiply, that's all. You can finish here, but you can advance this and you can do much more with this nice example. What you can, again, you can show some UML use case diagrams. Just design what you can do with, if you extend the system for everybody to use on the web or as an application, what you need more, not only one hard-coded exchange value, yeah? So how currencies are handled in real life? Just show this analysis of a problem before you go to the code. This is very important. So for example, we have some currency code, some names on the window, and buying ratio, sell ratio. So how to represent such things? Propose such a data structure. So we have all these records, organized, and show, at this point you can show map. So, okay, very simple database, yeah? You have the key and the value. Show how to design classes with UML class diagram at this point. So I have the T currency, and I have currency exchanger, which contains in the map a couple of these currencies. And I can add some currencies, and we can show some code, explain namespaces using, again, the definition of T currency. As I mentioned, the code is on the web, so you can download it. Again, the constructor, you can show two constructors in one because this the default values, so this is parametric and default, some helpers. Also, how to organize the map using, just to save on typing, novel data structure, very useful. It is private in this class. And also, what students hate, show the concept, not tell them, you must write comments, period. Why? Because you will make better code. Just go on. Show some benefits of writing comments. Your code will be self-documenting. This is another methodology of writing good code. Yeah? And we can go further on. We can build a component out of this, UML component. We can build a static library. And now we can add another problem. We need to download buying ratio from the web. So we need to use HTTP. And we have different operating systems, so we can build such a bridge handle body pattern to have this client, and depending on the system, show some sequence diagram of this. So you teach more on occasion. Then finally you show some GUI. You can add, because it was terminal version, now you have some GUI. This is FLTK, but you can use whatever GUI you wish, and extend further. So we can incrementally build or leave the students, you can build more upon this. And this is very important, code refinement under teacher supervision. So some patterns, look at this. We have this card game, everything is public. I ask why? Because it is faster to access. Yeah? I mentioned, I asked to initialize values. Why I didn't? Because to speed up computations. Yeah? So this is the answer. Things like this. I found something like this in the student just recently. And I'm asking why this? Vector of pointers, because card reference did not compile. I asked not to use new. Yes, but I found this on the Stack Overflow. Indeed, he tried to make something like this, and this didn't compile. And actually, compiler was not helpful in this. If you compile this and you double-click this, you are redirected to X memory with this line of code. So this is why teacher supervision is so important. The first thing, why he tried to use a reference, but the second thing, once he tried, he could not resolve from this error by himself. But we can make a vector of int, so we can make vector of cards like this. It can be simple, yeah? So propose better alternative when necessary. Always explain why. And don't leave the code behind. So explain why this reference didn't work and so on. Not, okay, it should be this way. Why? Because I'm your professor. And pause for a moment. Does it resemble the pair programming and code review methodologies? So you are teaching them more. You are teaching them how to make software development. Yeah? All these methodologies on the way. And we have some final slides. The world didn't start today. What does it mean? How to prepare students for legacy code? What is a programmer's life like? Can we address employers' expectations? Some at least. We have contact with the companies. This is very important. Is teaching C that bad? No, but in proper order. So what's more? Well, we teach modern C++, but remember about this environment. So even if you buzz against this OpenMP, GL, other libraries, you will find pointers and C code and even this is still valid construction in C++, main like this. So people will see this. So you need to explain at some point why is this working and what it does. And there is a lot of old legacy code in companies written by generations. So even if the code is correct, it is written in old fashion or even in C. So what to do with this? The young students are finishing, graduating, and going to the company, and they ask them to continue their code. Okay? How to do refactor, wrap up. While teaching modern C++, we need to introduce lower level constructions, also C. And the final thing, life goes on. More hints, C technology are changing rapidly. What does it mean? We need to learn ourselves as well. So we need to improve our skills and the skills of our team. Constantly increase potential of your teaching team. You don't teach alone. There are dozens of lectures, but we need to be careful. And also there are groups like this study group. I am a member of it. I will mention about this in a moment. So this is this proposal for study group, and is the group accepted by C++ Standard Committee. And what we do, actually it was established by J.C. Van Dinkel and Christopher Di Bella in 2018. And you can find the guidelines these are guidelines for teaching. This is not the book for teaching. There are guidelines how to prepare classes. So you can read more about this, but the most important things are, this is guidelines for content to be covered by courses, not some common misunderstanding also. Suggest resources and present example of a curriculum for specific courses. So this is some meta document, I would say. But you can also join us, and you can write. And so finally, what materials? CPP reference, very good, but can be intimidating for the beginners, yeah, because it is we can find everything there and up to date. Stack Overflow, beautiful. Primary source, any information, but any, and I mean that. Also many troubles. So, but they will use it, your students. This. So make sure you warn them just to look up the date of the post. It can be 10 years old or something. Core guidelines, beautiful, but not for very beginners. It's just to advance if you are in this middle group of object-oriented programming. Gigs and other many, but you can propose something to students what you like. What books I like? I like this book, but it is a little bit older now. This is a must, but for advanced students. This is also very nice book, but also not for absolute beginners, and not for the entire course. It is just overview. I like this book, but it is also 2014, so it's 8 years old now. This book is highly recommended by myself, Nico Yosutis, C++17. He's finishing his book on C++20. And also, I wrote my book, so you can look it up, Introduction to Programming with C++ for Engineers. Well, elaborating on all of this, what I shown today. So regarding these things, we have in the book organized 3 semesters. Basics, semester 2 is advanced and object-oriented, and semester 3 is after that, more advanced parallel programming. And at the end, in appendix, we teach C, actually. You can find the materials. If you Google up my name, you will find it. It is available on Amazon, but the code is free on GitHub. You can find it quite easily. There is also this Ford compiler example on my webpage, so it is another advanced example for advanced students just to see all this unique and SharePoint. No kidding. Okay, conclusions. Quality of the software of the future depends on the quality of education today. But not only, we love C++, so make it live longer. We need young blood. We need students, enthusiasts. All our students. And some become teachers, but many of us are teachers. Know your students, they need wishes and well-organize the classes. Think of choosing the right features, 2080 rule. Remember about this. Provide good examples. Keep things simple and in the right order, but be agile. Teach in a repeated manner, increase the level, the spiral model. And very important, teach not only C++, but teach in the broader framework of computer science, software design, UML, data structure algorithms. A little bit, you can have this in examples. Don't forget about the programmers' companies, the legacy code, and keep on self-training, always increase skills of your team and yourself. And thank you very much.